Hi, I'm John Marston, Civil Engineering Source Associate Editor for the American Society of Civil Engineers, and your host for ASCE Interchange Live. Thanks for joining me today for a discussion on developing intelligent infrastructure for the future. My guest today is Mariantonieta Gutierrez Soto, Assistant Professor of Engineering Design at Penn State University. She's also the director of Dream Structures Lab, a research group focused on the design of resilient, engineered, autonomous, and multifunctional structures. That's the DREAM acronym there. Welcome, Mariant. Thanks for taking the time to join us today.
Well, good morning, John, and thank you so much for the warm welcome and the opportunity to share the ongoing work at our Dream Structures Lab.
Great,
Happy
terrific.
to be here.
Terrific, yeah. So, with the threats of environmental and other complex hazards, civil engineers must build systems that are smarter, more sustainable, and more resilient than ever before. And 21st century innovations present a unique opportunity to design a new generation of smart infrastructure. So, artificial intelligence is a hot topic when it comes to discussing smart technology. Could you explain exactly what AI's role is in smart structures?
That is such an interesting question, John. AI is everywhere now, and a really easy way for people to, when they hear about AI, they think about robotics, right? Systems that are able to adapt and do things autonomously. And the way we can use AI in smart infrastructure has been used in different ways. You have people that study autonomous construction, people that use robotics for building things and 3D printing structures and so on and so forth. You can have autonomous vehicles, right? So nowadays, self-driving cars are being really popular and often are associated with that. You have space shuttles, right? Systems that are able to automatically do things at different environments. The way we do it in the Dream Structures Lab is that our building is able to interact with the environment and they're able to adapt in worst case scenarios. So one of the things that we are really interested in about researching is looking at natural disasters, which is the biggest challenge that infrastructure can have. So, how do we leverage the innovations in the artificial intelligence community so that we can make our built environment smarter in a way that is able to respond and adapt to changing conditions? So for us, when, or at least a typical terminology using AI is this idea of an agent or an agent-based model or multi-agent systems, right? So different communities define them differently. And the way people define an agent is just something that has some sort of intelligence that is able to perceive something from the environment, and based on what it's perceiving, it makes some sort of action. And one way that many of us may have experienced this is when you have these autonomous doors, right? The ones that open and close if they perceive something that is closed, or lights that turn off if people are moving or not. Or if you go to the bathroom, you put your hands underneath something and water comes out. So that's one way of having a simple reflex agent. And it's just a really fancy term, but it's something that nowadays is just more commonplace, especially at places where you have like airports and things like that, right? So you can see how these agents are already in place. Now, this idea of buildings that are able to react with the environment is fascinating for us. And because we're looking at natural disasters or extreme events, then we want to be able to have our buildings detect information from the environment, right? And to detect things, you need sensors or some way of capturing information of what is happening surrounding you, like changes in temperature, the wind loading, or an earthquake, right? And sometimes these are the worst case scenarios. And okay, so you're capturing information, you're processing the data. Sometimes you can play the doctor of your building or your bridge, and you're monitoring its health, right? So structural health monitoring has been in ASE for many years, and there's a whole field dedicated on trying to monitor if my bridge is still healthy, right? Quote unquote, is it maintaining those conditions, especially over the years, right? So sometimes when you design something for a particular loading condition, given the changes, sometimes that original design 100 years ago may or may not be okay now, right? Especially when you see the codes updating every so often. And for us, we find it interesting to instrument. We're gathering all this data from the environment, we're gathering data about what is happening within the building. But then for us, it's really important to fight back. So, what can you do? How can you adapt? How do you make it so that in case you're having these vibrations that might be damaging, can you do something back like you would do in a vehicle, right? So a lot of times these, new vehicles that are coming out, you don't feel the bumps on the road, right? They have shock absorbers and you have a smooth ride, and that feels great. So in similar ways, you can add similar devices like damping devices. There are some people have been more accustomed, right? Like some have been integrated a lot in their infrastructure for fluid viscous dampers and so on. And that's one of the things that we do. So we instrument our building with protective devices so they can adapt, and we find ways for that to happen. Mhm.
That's pretty fascinating stuff. Yeah. So, what is evolutionary game theory, and why is that important to consider when you're designing smart infrastructure?
So that's a really great question. So for us, evolutionary dynamics, evolutionary game theory is often used in political science and economics because it's used to understand how people make decisions or how communities change over time. It's the idea of modeling mathematically how people are making decisions. So game theory, usually you have prisoner's dilemma or you have other games that have been used and modeled mathematically. And the idea that the way we use it is that we want our buildings, our infrastructure to react and think like people, right? So just like I mentioned before, we're gathering information from the environment and we wanted to have a certain response. But then how do you do that? And then the computer, like the building, will have a brain that is able to make decisions. And that's how game theory comes in. We're giving our buildings and our bridges a brain and a way for them to make decisions. And we use game theory that is used for modeling rational decisions to do that. And we look at, minimizing resources that you need to accomplish certain goals and being able to like make it just like you and I would, right? If you see somebody falling, you don't need to know everything about that person to help them. But similarly, if a part of the building is experiencing some sort of damage or some sort of change during the life cycle, then maybe we can find a way to change that load path so that you can help each other out. So certain parts of the building may be able to help others and so on.
Okay, cool. So, how can engineers embrace and apply bio inspired concepts when designing smart structures?
That's great. And I think civil engineers have been inspired by nature since the beginning, right? We have always been looking at ways to learn from nature. What are certain good things that we can adapt? And you see it a lot, especially with building facades that open and close automatically, similar to how, animals breathe, like their skins and how they were able to regulate their temperatures by opening and closing. So there's just a lot of really important bio inspirations that could be used for that. We have also looked at redesigning an entire urban community so that it mimics how the aquatic life. So we had a group of students that looked at how can we learn from the aquatic life environment to see if we can find a way to mitigate from hurricane wind speeds. How can we redesign an entire urban environment? Or nowadays that you can use maybe 3D printing for your roof, like what is the optimal shape? If you didn't have limitations on the shape, then maybe you can gain information from nature. In particular, this group was looking at different type of fish and their shapes and how to minimize drag and things like that for improving the aerodynamics for extreme events.
Hmm.
Yeah.
So, what other key factors should engineers focus on in their design plans when it comes to smart structures?
When it comes to smart structures, there's a lot of planning that has to take place. And it's really a conversation that involves different stakeholders. So, being able to have the governance in place, law, policy, having a clear plan on long term benefits, because it is going to be an upfront cost. So there are going to be some things that are during the planning stage that it has to be integrated so that we can all, it's not just the structural engineer, but just like every other project, you have other dimensions that need to be included in those conversations.
Hmm. You're familiar with ASCE's Future World Vision, right? Where smart cities are one of the 6 trends driving the future built environment. So, what are the obstacles limiting the wider adoption of these concepts?
And I really like the ASE Future World Vision. I think the it's a really great opportunity for the next generation of engineers to really get into like these areas because you can see more and more how infrastructure is no longer just static, but is how actually adapting and how we can integrate smart mobilities and things like that. So now that it requires so installing new sensors and upgrading communication networks and things like that is going to be an expensive thing, right? And sometimes you require the internet, right? So being able to have interconnected components and having that communication and compatibility. One of the biggest questions that often comes about is this idea of privacy, right? Privacy and data security. How are you managing that? And so, like a lot of times, you can see it, there are certain generational gaps, right? Like not all residents in a certain smart city will have access to technology and the digital infrastructure. There might be some learning there, and you want to be able to make sure that you're giving equal access to all the residents. And of course, you have regulation and legal challenges, and they all vary depending. Just even within the U.S., you have to look at how different communities, address certain things like that. And there's also resistance to change, right? So a lot of times, you know, in other engineering fields, like in your phone, right? Like the latest technology gets implemented in the next generation phone and it gets adopted immediately. But in civil engineering, sometimes it takes more time, to embrace technology like that because I think and it's understandable, right? Because, like I said early on, if your phone runs out of battery, that's okay. If your phone loses connection or doesn't have internet, or if you had difficulty coming to this meeting, right? Those are technologies that we are okay with troubleshooting. But during extreme events, or if you're looking at a large scale building and you're impacting hundreds of people that are going to be in that office building during that one time, there are going to be some, you want to make sure your technology is working. So in those cases, you have to work on redundancies. But it's also one of those things that many researchers are really interested in looking at. The cybersecurity space and all these other challenges are also opportunities for design. So we're in engineering design, and when things are failing, those are opportunities for us to be creative and finding ways to improve upon those.
Yeah, I was about to ask about the kind of infrastructure systems you think that ought to be prioritized when you build a smart city.
Yeah, no, absolutely. So, of course, robust high speed communication network is going to be a priority, especially when you're connecting different things. So, for example, you want your autonomous car to be able to communicate to your smart bridge to figure out the best evacuation routes, maybe during extreme events. You want your buildings to communicate to make sure that you have all this information. So, of course, all these different sensing systems, all these different technology will be required to be integrated. And for that, you also have to think about the energy management, right? So prioritizing energy efficiency and renewable resources, smart grid systems, and so on and so forth. Those are going to be the ones that should be prioritized. And of course, governance. Who's handling this data? Who's in charge of it? How can we regulate it appropriately?
Huh. Okay. Well, let's see here. We have this a guest question here. What is the role of semantic web technologies, especially ontology, in providing smartness to infrastructure to adapt to the environment?
Oh, and there's a lot of words there that I haven't
Yeah.
heard before. I'm wondering if the
Yeah.
guest will expound on his question. I'm not really sure what he meant by ontology. Um, how would you
Yeah.
interpret that
I
question?
hope maybe he could follow up. Maybe he can follow up. But yeah. I'm not quite sure. This is pretty intricate kind of question. I'm not sure how we address that, but I hope that the viewer will follow up with some clarity here. But
Absolutely,
yeah,
absolutely.
so it looks interesting. In the meantime, I'd like to know if you think how smart systems will integrate with existing infrastructure.
That is a really good question because a lot of times we get really excited about instrumenting, critical parts, right? So your building, your bridge will have areas that are maybe more susceptible to damage or that you predict that there will be the ones that are more vulnerable, but then you cannot access that beam, right? You don't have access because there's the ceiling is there, or maybe when they instrumented certain things, they put, they cover it up. So then how do you, place the information there, or how do you do maintenance? So that's another thing that is going to be very important. So assessment and planning is going to be very important. Interoperability standards. So having really clear standards to follow. Like if you wanted to monitor these particular things and developing the standards to do so effectively, I think those are going to be some really good ways for making sure that we have the smart systems integrated into smart infrastructure, to existing infrastructure.
Okay. So, what kinds of smart city innovations can residents look forward to? How they be able to see it in their everyday life?
Yeah, no, absolutely. And it's a really great question because when I was a grad student at The Ohio State University, Columbus, Ohio actually got selected as a smart city. And it was one of those, 77 cities competed, and only in Columbus got selected as a smart city. And when we were really curious, because out of all the other competitors that you might be more expecting, right, like New York or San Francisco or Austin, Texas, or some of these big cities, picking Columbus was kind of interesting. So we dig deeper about why did they pick Smart Columbus as their city, and we realized it's because they prioritize the residents' needs, and there was a really interesting user-centered design. So it was not just the fact that you were deploying smart vehicles everywhere, but it was the intentionality about connecting communities that may not have access to healthcare. Like that was one of the prioritizations, especially the elderly or like the prenatal community, that they needed a way to get to the hospital right away, where public transportation may not work there. And so they were really intelligent about making sure they integrated the needs of the community in ways that were really interesting. So, of course, public safety, advanced surveillance systems, smart street lighting, energy efficiency buildings that will reduce the cost in terms of spending energy where maybe you're not using that room, so maybe that room shouldn't be have so much air conditioning. But urban green spaces, right? So if you have a garden, maybe you have an autonomous irrigation system that you don't have to worry about watering, but it's autonomously growing your foods, or smart housing, right? So being able to have
Mhm.
security systems and energy uses and just convenience on day-to-day life.
Neat.
Yeah.
You got another question from the audience. What are some of the more important pieces of smart infrastructure that can be implemented now or in the next 5 years?
That can be implemented now. Well, it's really interesting because I feel like a lot of people have already integrated some of the smart housing. Being able to have these smart home automation systems that have remote control of your appliances. So there are already some really quick ways to do that. Now, we focus on natural disasters, right? So we want to be able to say, well, look at these worst case scenarios. But a lot of times, people want to invest on things that are going to have an immediate return of that investment, right? So you want to be able to have that, some people have Ring or something in their door so they can see who's at the door, and or they can see their packages arriving and talk to them while they're not even at home. So some of these integrations of technology have already taken place. Some people have autonomous, watering systems for their lawn and things like that. So they're already, and the biggest robot is, the vacuum cleaner, right? So a lot of people who has not used a vacuum cleaner, right? And you have it on and off and you use it all the time and you have a washing machine. So
That's
there
right.
are
Yeah.
already, smart infrastructure, but I think it's being aware, increasing awareness about this technology and really intentional about what can we do with the changes that are being perceived, and maybe integrating some of these devices, or even just learning more about what will make my infrastructure better, right? So can we make it so that we design it so that it can be, survive the worst case scenario and save lives in the long term.
That's great. Yeah. All that Internet of Things stuff and stuff like that. Yeah. So yeah, that's a good place to leave it. Yeah. Thank you, Mariant, for joining me today for what has been a fascinating discussion on designing the next generation of smart infrastructure. For more,
Absolutely.
oh yeah, glad to have you with us today. For more information on ASCE's Interchange series, visit asce.org/interchange. Thanks for tuning in today, and we'll see you next time on ASCE's Interchange Live.